When we look at part 2, number 12, it says to use a calculator. Now we're going to use our tables on the calculator, okay? We're going to use the table on the calculator. So to do that, just go to y equals, clear out your memory, type in the equation, x squared divided by, put in parentheses, x squared plus 2. Now, I don't care what the graph looks like, I just want to go to the table, second table, and I want to get the first 5 terms. Oh, look, I'm at 19. I got to scroll all the way up to 1. Okay? There it is. So to get my first term, I get 0.333. My second term, 0.667. My third term, 0.818. My fourth term, 0.889. And my fifth term, a sub 5, 0.926. And what I'm going to do is I'm just going to sketch those. Not too hard to do. 1, 2, 3, 4, 5. And I might start at 1/3, and it looks like it's approaching 1 if you look at the graph. So 1/3 at 2 at 0.67. I keep getting closer and closer to the 1. As a matter of fact, that 1 is our horizontal asymptote. So it's approaching it, kind of like a curve right here. And we can tell that by looking at here. This is a rational function. This is our Bobo-Botten. The powers are the same, so we use our ratio. Y equals 1 is our horizontal asymptote. All right, now, down below, we are going to write expressions for the nth term. So what we're looking for is how do we get a sub n? And you have to look for patterns on this one. It's not so bad to do. Now later on we're going to take a look at 2 special ones, geometric and arithmetic sequences. And that'll be a little bit easier for a problem like number 13. But for now, just take a look. See if you notice the pattern. I noticed something. Take a look. 3, 7, 11, 15, and 19. Well, I try to think, well, what do they all have in common? Well, this is almost 4 times 1. We're starting with n equals 1, so we should try to start with n equals 1. 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. What's the pattern here? This is 4 times 4, which is 16, and this is 4 times 5. Now, it's not quite 4 times 5, but notice, what's the difference between all of these? 4 times 1 is 4, I got 3. 4 times 2 is 8, I got 7. 4 times 3 is 12, I got 11. Very good. They're taking 4 times whatever this is, whatever this term number is. These are my term numbers. That's my n's right there. So they're taking 4 times whatever our term number is and minusing 1 from it. Very good. So try that again if you need to. Now number 14, it looks the same. Well, take a look. 2, 4, 6, 8, 10. That's a little bit easier. That's 2 times 1. 2 times 2. 2 times 3. 2 times 4. 2 times 5. Again, I'm taking 2 and multiplying it by my term number, n. So I get a sub n equals 2 times n. Now, we would almost be done except for they are alternating signs. Now, anytime they are alternating signs, we're going to multiply this by -1 to some power. Okay? We're going to multiply by some -1 power. This means that we are alternating. Okay? So anytime you alternate signs like this, we always have to have that -1. The problem is, what does the power have to be? If you start off with the positive, you're generally write n plus 1. And the reason we do that is, if I let n be 1, without the 1, if I let n be 1, take a look here. I get -1 to the first. It's negative. My first term should be positive, not negative. So what do? I let it be plus 1. And now, because I'm starting with n equals 1, 1 plus 1 is 2. -1 to the second power is even, which makes it positive. Okay? And you can verify this by just taking a look at a couple, okay? Let's try a sub 1. 2 times 1 times -1 to the n plus 1 is 2. That becomes, positive 2. A square, a second, 2 times 2, -1. 2 plus 1 is 3. That's an odd power. Well, 2 times 2 is 4. But because that's an odd power, makes it negative, which is what I wanted. So you can check these. All right. Number 15, look for a pattern. The bottom's not, look at the bottom here. 3, 9, 27, 81. That's pretty easy. That's 3 to the first, 3 squared, 3 cubed, 3 to the fourth. So that's pretty easy. 3 to some term numbers right there. Okay? So when I want to get a sub n here, the bottom's pretty easy. It's 3 to the n. But let's do the top. 1, 2, 4, 8. Now that's easy. 2 to the first, 2 squared, 2 cubed. Just like me. So what do you think this is going to be? Very good. 2 to the 0. So for the top, we know it's going to have a base of 2. But remember, we want to start with n equals 1. We're starting with n equals 0. So the question we have to do is, well, we start with n equals 1. I need that to become 0. So if n is 1, how do I make n equals 1 0? Subtract 1. We subtract 1 to make 0. Because that's where I start with. And there is my term. So what I would like you guys to do is see if you can come up with number 16. And we're going to take a look at number 17 here together. Okay? So for number 17, 1 plus 1/2, 1 plus 3/4, 1 plus 7/8, 1 plus 15 over 16, 1 plus 31 over 32. Now the first thing I notice is every single one of these has a 1 plus. So I'm going to write that part down and the fractional part. Looking at the bottom, it's not so bad. 2 to the first, there we go. 2 squared, 2 cubed, just like me. 2 to the fourth, and we've already know this one, 2 to the fifth. Well, looking at the pattern, we know it's going to have a 2. But look at this. I don't have anything here on the bottom. So it must be 2 to the what? Go backwards. 5, 4, 3, 2, 1, 0. So just like before, we're starting with n equals 1. We start with n equals 1. But be careful, they're starting with n equals 0. So how do I make this 1 a 0? By subtracting 1 right there. So let's do the top. To get to the top, 1, 3, 7, 15, 31. This one's a little bit tougher. Wow. This is 2 minus 1. 4 minus 1. 8 minus 1. 16 minus 1. 32 minus 1. And I may be asking, well, where do we get that from? Well, how does that help us? Well, this is 2 to the first minus 1, 2 squared minus 1, 2 cubed, that's me, minus 1, 2 to the fourth minus 1, 2 to the fifth minus 1. So right away, we know it's going to be 2 to some power n minus 1. But be careful, we have to go back here. This is 2 to the 0. Again. And so what's the pattern going to be? We start with 0. So again, I have to subtract 1. This is a tough one. Try this one again, okay? And we'll go over the rest of these tomorrow in class, okay? And we'll see you then. Bye.